So in this second part of lesson 87, we're just going to do some examples. So as we just saw, as we look at these rectangular prisms, now the thickness isn't shown on this one, but we could sketch it in here. We have this thickness here of the rectangular prism, and the circumference is 2 pi r, which we notice when it's wrapped around the y-axis, that's just x. So here's 2 pi r times the height. So this is really saying the area here, and then times its thickness, which is dx. And so let's go ahead and use this a few times. So the region bounded by the coordinate axes, so the x and y axis, and the lines y equals 5 and x equals 3 is revolved about the y-axis. Find the volume of the solid generated. So it does help to sketch this, the region bound by the coordinate axes. So by x and y, by y equals 5, well, y equals 5 is a horizontal line, 3, 4, 5. So that's this horizontal line. So let's do this. And then the vertical line, x equals 3, is wrapped around the y-axis. So wrapped around the y-axis, and we want to find the volume. So it's going to be a cylinder, and we can easily find the volume of a cylinder just using our geometry formula, but we're going to practice this. So as we learned in the first video and from above, volume is going to be 2 pi r h times the thickness, which is dx. So you could think the width. So volume this is the volume of one rectangular prism, one layer or one shell that's peeled off. So we're going to integrate, and we're going from 0 to 3. 2 pi r is just the x value. So that's the x value, so 2 pi x. The height of this, the height in this case always stays the same. So the height is the function. So this is the f of x, which is just y equals 5, so 5. And then times the thickness, that's the dx. And so we can simplify this a little bit before we integrate. We have 2 times pi times 5, which are constants, so that can come outside of our integral. So we have 10 pi and the integral from 0 to 3 of x dx. And we could use a calculator to evaluate this one. This one also can be done pretty easily, just working it out. So this is going to be 1/2 x squared, evaluated from 0 to 3. So we have 10 pi. Put in the 3. 3 squared is 9, so we have 9/2. Minus, put in 0, you get 0. And so we have the volume. If you multiply this out, we have 90 pi over 2, which is 45 pi. And this is going to be units cubed. So we can check that because we know volume of a cylinder is pi r squared times the height. So the radius of this one is 3. So pi times 3 squared, and the height is 5. So we have 45 pi. All right, so there, yes, we can use geometry, but we wanted just a fairly simple one to practice this shells concept with. So moving on, the region bounded by y equals x minus 1. The x-axis and x equals 4 is revolved about the y-axis. Use the shell method to find the volume of the solid generated. So once again, it does help to have a little sketch here. So we have y equals x minus 1 So it's going to go through -1. It will have a slope of 1. So we could sketch this. There's y equals x minus 1, the x-axis, and x equals 4. X equals 4 is this line here, vertical line. So we're going to take that triangular region and we're going to revolve it around the y-axis. So it's going to go around the y-axis. So here we go. We're going to use the shell method. So our volume is going to equal the integral from 1 to 4, because that's the values, the beginning and ending of the interval. And remember, it's going to be 2 pi times the radius. Well, the radius is always x, 2 pi x, times the height. Well, in this case, the height changes depending on where we are in this graph. So this red one has a different height than the end one down here, this blue one. So the height is changing. Well, the height is the y value. So the height is the y value, and we know that y from the directions is x minus 1. So that's what goes in for the height, x minus 1. And then the thickness is dx. And so we want to find this volume. So volume equals, we can factor out a 2 pi. And integral from 1 to 4. We'll distribute the x here, so this is x squared minus x dx. We could obviously solve this by hand. Let's go ahead and do this on the calculator. So we want 2 times pi, and we're going to multiply by the integral. So math 9 is what it would be on a TI-84. So we got from 1 to 4. And then in here we want x squared minus x. Oops. Lost the whole thing. 2 pi times the integral from 1 to 4 of x squared minus x dx. And we can hit enter, and we see we get the volume is 84.82. Now this has a pi in there, so if you want it in terms of pi, I should put units cubed. If you want it in terms of pi, you could take this value on your calculator and divide it by pi to see what that is going to be. So we're going to take our answer divided by pi, and we see this 84.82 is 27 pi units cubed. So that's the exact answer, and then we have an approximate answer of 84.82. All right. Probably increasing in difficulty a little bit here. Use the shell method to find the volume of a solid form by revolving about the x-axis. So this time we're going about the x-axis, the region in the first quadrant, bounded by x equals 4 minus y squared and the x and y axes. So that should say the in there. All right. Well, let's put a sketch in here. It's in the first quadrant. It's bound by the axes. And then we're going to graph this. Now, oftentimes, so we should know this is a parabola, but it's a horizontal facing parabola. X equals negative y squared plus 4. So this thing is moved right 4. And it's opening to the left because this is negative So here's the graph of that parabola. We only need the first quadrant because we're using this region in the first quadrant, and it is being revolved around the x-axis this time. The x-axis. So this time our shells are going to be these. So this, like this little rectangle being wrapped around the x-axis, and then maybe we have this other red one that would be wrapped around the x-axis. So we're going to have to think accordingly as we think about our shells. So our volume is going to be the integral. Now it's going around the x-axis, so this is going to be in terms of y. Our indices are going to be terms of y, so we're going to go from 0 up to 2. And if you want to know where that crosses the y-axis, you would put 0 in for x. It does cross at 2, and you could subtract 4, divide by -1, take the square root, and we get 2. So we had to find out where that crosses the y-axis. Now we want 2 pi times the radius. Well, this time the radius is the y value. So we're going to put y in here. So 2 pi r times the height. So maybe I should draw this. Let's draw this red one that will be wrapped. So it would be like this long rectangular prism that's wrapped around here. So here's the 2 pi r is this length. The height is this. Well, this time the height is our x value. So the x value is the height. Well, what is x equal to? X is equal to 4 minus y squared. And then the thickness is, it's not dx, it's not the change in x, it's the change in y, so dy. And so there is the volume, the integral that will give us the volume, so we can factor out a 2 pi. This is from 0 to 2. We can multiply this out. This would be negative y cubed plus 4y dy. And we could integrate that just with our pencil and paper. We could work that out. We'll go ahead and just plug this in like we did the last one. So we got 2 pi times the integral from 0 to 2 of, now I'm not using the letter y, so when I plug this into the calculator, it doesn't matter what the variable, what letter necessarily we use, so I'm just going to put x's in all of these. So we're going to put negative x cubed, oops, did it again, so 2 pi times the integral from 0 to 2 of negative x cubed plus 4x dx. And we get volume is equal to 25.13. Again, if we want to get it in terms of pi, we could divide this by pi. So divided by pi gives us 8. So we have 8 pi units cubed for that one. So we're working through that shell method. Several examples here. So here we go. I think this is our last one. Use the shell method to find the volume of the solid formed when the region bounded by the x-axis and y equals negative x squared plus 2x is revolved about the y-axis. All right, so we want to look at this. We want the volume bounded by the x-axis and then this parabola here, and it's revolved around the y-axis. So this parabola is facing downward. We could put it on a graphing calculator if we want to find some things that we need. Let's go ahead and work through this to find the y-intercept. You can plug 0 in for x. So y is going to equal 0. And to find the x-intercepts, we can plug 0 in for y. So we have 0 equals negative x squared plus 2x. We actually already know it goes through 0, 0. So we could factor out a negative x, gives us x minus 2. And so the x-intercepts are at 0 and 2. So here's 2. And so this graph is going to look something like this. So let's see what we can do here. Can we use this to figure this out? So volume is going to be equal to the integral. And we're wrapping around the y-axis, so we're going from 0 to 2 of 2 pi times the radius. All right, well, the radius is just the x value, times the height, that's the function. So what function do we have here? That function is negative x squared plus 2x. And the thickness is going to be dx. And so it was very important in this case. We had to find the x-intercept so we could find out what goes in to these index spots. So there's our equation. We can simplify it. We got 2 pi from 0 to 2 of distributing this x in here, negative x cubed plus 2x squared dx. So we can evaluate that integral. It's more efficient just to type it in the calculator. So let's see if we can do it without messing up this time. 2 pi times the integral from 0 to 2 of negative x cubed plus 2x squared dx. And so we get 8.38 units cubed dividing by pi, 2 2/3 units cubed. All right, so that's how you use the shell method to find the volume of a solid of